calculator. I should have been doing this since day one, but I didn't because most people didn't have calculators at this point. But at the beginning and end of every assessment, the expectation is that you guys are clearing your calculators. Okay, so from now on, I'm going to ask you to do that. Before I give an assessment out, I'm going to ask you to show me that your calculator has been cleared, and then when you hand it in, you're going to show me that you've cleared it once again. Okay, I know that this seems a little bit over the top, and to be honest, at this school, this really isn't such a big deal. I've never experienced this at this school, but at other schools, you wouldn't believe some of the cheating that goes on without clearing your calculators. You can enter a lot of information in here, right? I've seen people in first period record the entire test on their calculator, give it to their friend who's writing the same test in last period. So that's why we ask you to clear it at the beginning and the end of every assessment, okay? On a standardized test, like a diploma exam, this will be the case as well. We even go so far on those exams to say that you have to put the case of your calculator under your desk because people have written notes and stuff inside the cases, okay? Question, yeah?
Do we clear them or they have an exam mode?
So, if you have a TI Inspire, those have exam modes, but the other ones don't. That doesn't look like, is that an Inspire?
It's an 84 plus CE, but I saw some stuff on Google on like YouTube about how to put these in exam modes as a key combination.
Yeah. No, if it can be cleared, we're going to ask you to clear it. Now, my previous school before Central went so far as on those exams, you actually, to properly clear them and put them in exam mode, you actually have to have another Inspire and hook it up to it and do it somehow that way. So I just remember the assistant principal having to run around at the beginning of all the math science tests with his Inspire doing that. At this school, we just say put it in exam mode. But to be honest, the reason why that happened is because at that last school, students got caught cheating on a diploma exam by the province. They do data analysis. So they ask for a seating plan to know where everyone's seating. And if your exam looks similar to someone who's sitting near you, they can actually give both people 0. Right? So on diplomas, when I'm supervising, I'm constantly walking around saying to people, cover up your answer sheet, cover up your answer sheet, cover up your answer sheet. Because you could be sitting there, someone could be looking at your answer sheet, you could get a 0. Right? And the school doesn't actually have control over that. It's all done through data analysis. So and I think the reason why the last school was like really stringent with this stuff is because that actually happened at that school. Whereas it hasn't happened at Central, so it depends on. It's more complicated than you would think supervising exams, right? It looks like we just stand there and walk, but I'm usually looking to see, is your paper covered up? If you go to the washroom, cover up your answer sheet, that sort of thing. I'm looking at eyes all the time to see if eyes are wandering, that kind of thing, right? Because I don't want anyone, particularly the person that is being copied off of, I don't want them to get hurt. Right, so that's kind of why we do it. But yeah, that's the expectation. You're going to be asked to clear your memory before and after. Okay, so we're going to go through this one by one because it's different processes for both. If you have a Texas Instrument, a TI, clearing the memory. On the Texas Instruments. Okay? You are going to hit the second button. Okay, so I'm going to hit second. And then hit the plus sign. You can see there's a little MEM above that. And that's what you're trying to access. Okay, so I'm going to hit second plus, and then you are going to hit number 7 for reset. Do you guys back there have a question? Okay. Okay, So you're going to hit number 7. You don't, a lot of people think you have to scroll down and hit enter. You don't actually. You can just hit number 7 and it'll automatically go there. Yep.
There's a little reset button on the back.
Nope. I'll look at it, but this, I don't believe that that will suffice. Okay? So you're going to hit number 7 for reset. You're going to hit number 1 for all RAM. And then you're going to hit number 2 for reset. Okay? And then once you do that, you keep that screen on until somebody has checked it. Most of the time, except for the final exam in this course, that will be me. If I don't see this, I'm going to ask you to do it again. Because a lot of people do this and then they hit clear, and then I come around, they're like, I already cleared it. Okay? I actually have to see that screen. So leave it up, and then when you hand your test in, you're going to show me that screen again. Okay? That's the TI. On the Casio. Okay? Everything that you want to sort of get to on the calculator, on the Casio, is under menu. So hit menu. Okay, and you'll see a lot of different options. Depending on the version you have, you may see more or less versions. But for example, I'm hearing a lot of side conversations, and it's really, really distracting to me because I'm also kind of listening with one ear about what the question is, and it's just really difficult. And then I get sidetracked, and I start like mixing up my words, which is really not fair to everyone. So if you have a question, if you want to just ask your friend, just wait. Or if you want to ask me, ask me. Yeah. Do you have a question? Yeah. Okay. Okay, so everything that you want to get to is under menu. Now, when you want to clear your calculator, the menu item that you want to select is System. Okay, we're going to have to scroll down to get there. Just so you know, though, mostly what you're going to use on this is the Run menu item. That's when you just want to like run calculations, 2 + 3 = 6, that kind of thing, and number 5 for graph. Okay, to get to the system's right over here, so you scroll down, and then you scroll to the side, and you hit this EXE. I don't know what that stands for. Maybe execute? I don't know. Okay, so you're going to hit System, and then you are going to go to number F5, which is the reset. Okay, and those are all at the top here, so I'm going to hit this one. Okay, once you hit F5, this new screen will come up, and what you want to reset is the main memory, which is F2. So you're going to go down to F2, which is main memory. And then F1, it's going to check, do you actually want to do this? And you are going to say F1 for yes. And hit F1. Okay? And then you're going to leave that screen up so that I can see that that has been done. Once I see it, you can hit exit, and then go back to menu, and you can select whatever else you want to do. Usually you're going to go to run because you're going to want to do calculations. Okay, and this, when you hit run, you get to do like 2 + 3 = 5 or whatever you want to do there. Okay? So that's how you reset the memory. The rest of class, we're really going to focus on how do you use the graphing features. And what are some other things that you can do to find out specific information about the graphs? Okay, so I'm going to talk about the TI first, I think, and then we'll go back to the Casio. On the TI, When you want to graph an equation, you have to hit the y equals button at the top. And this is where you're able to enter in various equations. So I'm going to hit this guy. It's in the top left corner. And you're able to enter in a bunch of different graphs at a time. Okay? Depending on the model you have, they may come up in color. Most of them don't. If you have a really fancy one, it'll come up in color. You don't need the color. Color's not super important. And you can enter in whatever graph you want. So I'm going to maybe enter in the equation y equals negative 3x plus 12. Okay? Now, the negative sign. There are two negative signs, and this is true for both calculators. There's this one on the right, and then this one down at the bottom. The one on the right is for subtraction. So if you want to do 2x minus 3, you use that one. This guy is to make an integer or a coefficient negative. So in this case, to make the negative 3x, I need to hit this guy. Negative 3, the variable button. Okay? A lot of people think they have to hit alpha and then they can enter in the letter x. The calculator won't recognize that as a variable, because we typically use alpha when we're trying to type out words. So it won't actually know what you're talking about. The variable button is this one, right beside the alpha. X, T, theta, N. And that's just because those are letters that we frequently use for variables. So you're going to hit that guy, and then plus 12. Okay? So once you enter the equation, you can hit the graph button. And there is the graph, okay? Now, when we see the graph, remember the coordinate plane is infinite. It goes on infinitely in all four directions. And so we are just seeing a snapshot of this graph right now. And we are seeing a snapshot of x values between, on the left side, negative 10 to the right, 10. And vertically, we're seeing values again from negative 10 to 10. And whenever you reset your calculator, this is sort of the automatic window settings that are put in there, okay? We can tweak this though. And sometimes you have to do this, sometimes you don't, depending on what you're trying to graph. When you're graphing a linear function, which this is, we typically want to see both the x and the y-intercept in the window, okay? So I can see the x-intercept over here, but I can't see the y-intercept. It looks like it's higher than 10. So I need to make that higher. I need to make that maximum y value of 10 higher, okay? To tweak any of these settings, you hit the window button. Okay, so window changes the window settings. And now you can manually go in and pick whatever values you want. So we saw the x-intercept, that was okay, but we need to make this y max of 10 higher so that we can see the y-intercept as well. So I'm going to go down and hit 15. The process for this on the Casio is similar. You just have to hit a slightly different button to access this screen. Okay, and then I'm going to hit graph. And now it's changed that window setting, and I can see the y-intercept as well. Okay? All right, so that's one thing that's important to know. The other thing is everything that's under this calc menu that's above the trace button. This calc menu is going to allow us to figure out certain features of graphs. Okay? Some of them in a linear function being the x and the y-intercepts. The calculator will be able to tell us exactly what those are. Okay? I know that it looks like we can see what they are, right? If you look at the graph, you could probably tell what they are. There's a couple things you need to know about that though. Number one, in a lot of equations, that's not the case. And number 2 is that you cannot rely on your eyes necessarily, because this looks like it's at 4, and in this case it actually is, but it could be at 4.01 and we wouldn't know that, okay? So to be able to figure out information about graphs on the TI, you need to hit the second button, and then the trace button that has this little calc on top. And you'll see that a menu pops up. And this allows us to calculate 7 different things. Okay? In high school math, we don't do the last 2. Unless you take Math 31 or 31 AP. These are calculus features. Okay? So you won't use these unless you go beyond Math 30-1. In this course, we use 3 out of the 5. We use number 1, number 2, and number 5. Okay? Number 5 is an intersect. That's when you have 2 lines or 2 curves and they cross each other. And that feature allows you to find the intersection point of the 2 lines or the 2 curves. Okay? We're going to do that a ton in our next unit. So I'm not really going to talk about that today, but today I want to talk about the first 2. The first 2 allow us to find the X and the Y-intercept. Okay? So to get the X-intercept, well, actually, let's talk about the Y-intercept first. Once you get to this screen, gonna hit number 1 for value. Okay, so select number 1. And what this allows you to do is to enter in whatever X value you want, and it'll pop out the Y value. Now, if we're on the Y-intercept, what is the X value? 0. Yeah, so you're going to enter in X equals 0, and then hit enter. So if I put in a 0 and hit enter, it'll tell me that Y equals 12. Okay? Now you don't have to enter 0. 0 is just what you want for the Y-intercept. But if you wanted to know, what about when X equals -5, you could put in a -5. And you'll see that Y equals 27. Yeah? All right, let me try and troubleshoot. Try that. Okay. So that is the Y-intercept. Let's talk about the X-intercept. Okay? To get the X-intercept, okay, you have to do the second calc thing again to get back to that menu, but now you're going to hit number 2. Uh-oh. I'm just going to hang up on that. So you're going to hit number 2 for 0. Okay? Now, an X-intercept is often called a 0 as well. And the reason it's called a 0, you might call it the 0 of the function, is because it's the value of X when the function, which is on the Y-axis, is 0. Okay, so we call it often the 0 of the function because we know that the Y value is 0 there. Okay? You don't have to necessarily remember that. You might be asked that in Math 20-1 or 30-1, but for now what you need to know is if you want the X-intercept, you need to hit that button. Okay, so we're going to do that. And it's going to ask for a left bound and a right bound. Now what it means is this. Here is the the X-intercept rather. If you can imagine a vertical line right there. Whoops, vertical line right there. It divides it into a left side and a right side. Okay? If we're wanting the left bound, we need to move the cursor somewhere to the left of here. So I'm just gonna, I think my cursor is way up there right now. I'm gonna move it over here, and that's on the left side. And I'm gonna hit enter. And then it's going to ask me for a right bound. So now I need to move it to the right side of that point. Doesn't have to be super close, and I'm gonna hit enter. And it'll tell me that the 0 is x equals 4, y equals 0, which is the x-intercept. Okay, so once you get to here, it's going to ask for a left and a right bound. And then actually, before that, I don't know if you guys, or right after that, I don't know if you guys noticed, it asks for you to guess. And you just always hit guess, hit enter. Okay? I don't actually know why that's in there, but I'm not a computer engineer. Yeah?
It's moving, but it's not, I don't see the lines.
You have to hit enter.
So why do I put it, wait, so I hit enter after I get to the,
Once you get it to the point on the left that you want, you hit enter.
okay.
Yeah. Yeah.
Do we want it on either side of the x-intercept? So like your left bound is like a little bit to the left?
Correct. Your left bound is a little bit to the left. Your right bound is a little bit to the right, exactly. It doesn't have to be super close. Some people think they have to get it like right on that line. No, get it like relatively close, but it doesn't have to be super, super close. Okay? Yeah.
What are those for? Why do we need to put those in?
So the reason why you might want to, why do you have to figure out the left bound and the right bound?
Yeah.
I don't know. On the Casio, it's much easier, and I'm not a software engineer. I don't know. Like I did some computer science when I did my math degree, and I gotta say, if I was designing this, I wouldn't do it that way. But I don't know. Yeah, yeah.
I have no idea where to find the intercepts on the TI-85.
Okay, we'll try and talk after. Okay, I don't know either, but we'll be able to find a manual and hopefully work it out. Okay.
So is there a way to like reset it to back to its original?
If you want to just reset it, just press clear, and that'll all go away. Yeah. Okay, so that is the TI. Let's talk about the Casio. Okay. On the Casio, if you want to graph something, you got to go to Menu and Graph. And then select Graph. Okay, so I'm going to do that. I'm going to go to Menu. I'm going to go down to Graph and hit EXE. I don't know if that means execute or what. I'm executing this operation. And this very similar menu will pop up. Okay, so we're going to enter in the exact same equation. Again, I have to use this negative sign, -3. Here is my variable button, x, and then plus 12. Nope, delete 12. Okay, now to be able to graph, you actually have to hit this execute button again, and you'll see it goes down to the next line, and this equal sign is highlighted. Once you do that, these little options will pop up at the bottom. And what you want to do is you want to hit F6 to draw. You want it to draw the graph. Guys at the back, I understand that you have TIs and you're trying to work them out, but everyone who has a Casio is going to be distracted by you talking right now. Okay? So you will have a chance to work together, but just wait for 5-10 minutes. Thank you. Okay? So you're going to hit F6 for draw. And you'll see something similar comes up. Again, it looks like we need to adjust the window settings here. Okay, so to adjust the window settings, you need to hit F3 that says above it, V window. Okay, and here you can again go in and manually change these. It looks like we again need our Y max to be higher because we couldn't see the Y-intercept. So I'm just going to go down to where it says Y max. And I'm going to make that, again, maybe 15. And I'm going to hit execute. And I'm going to hit execute again. And then it'll come back to this graphing menu. Okay, and as soon as it does, you just hit draw again, F6. And there we go. Okay, so now we can see everything that we want to see. And our Y-intercept is in there, which is great. Now, finding these things on the Casio is way, way, way easier. So to get info on here, you are going to hit F5, which says G-solve. I don't know why it doesn't have the E at the end. I'm going to put it in because I'm like that. And you'll see that as soon as you press that button, a whole menu of options appears at the top. You can find a root, a max, a min, a Y-intercept, an intersection point. If you hit F6, there's more. You can do a Y calculation. So this is where you enter in an X value, it gives the Y value. Or you can do an X calculation. You put in the Y value, it gives you the X value. This is not actually a feature on the TIs. Okay, the TIs, you can't do that. And then this last one is an integral. That's a calculus thing. Okay, I'm going to go back to the original one because what I want, which is the X and the Y-intercept, is on this menu. Okay, Y-intercept is F4 because it's called the Y-intercept. Okay, so to get the Y-intercept, you're going to hit F4. And it just tells you what it is. You don't have to do anything else. It says x equals 0, y equals 12. Okay? To get the y, sorry, not the y, the x-intercept, you go back to that G-solve menu again. And on this calculator, the x-intercept is called the root. Okay? There's a reason for this. It's really going to come up a lot more in 20-1 when you start solving quadratic equations. But essentially, you can use a function to solve an equation, right? So if you're solving 0 equals x plus 4, you can write in y equals x plus 4, and then just look for the x value when y is 0. And that's why it's called the root. A root is a solution to an equation, the root. Okay. Again, you don't need to know about all that naming stuff. What you need to know is if you have this calculator, to get the x-intercept, you're going to hit F1 for root. And you don't have to do any of this left-bound, right-bound stuff. Just tells you the answer. X is 4, y is 0. Okay, so in that way, it's quite a bit more straightforward. It's also more straightforward for other things that are annoying on the TI. You can find a max or a min point. So if you have, and we haven't looked at this yet, but if you have a graph that perhaps looks like this, it has a maximum point right here, right? So that max feature, the F2 would allow you to find that. Okay, this one doesn't have a maximum point, so it's not going to give us anything if we press that button. Sometimes you can have one that has both. So it might look like this, right? Here is min, max, right? So you can find those points using those features of the calculator. And the TI, again, if you go to second calc, you'll see that there's a maximum and a minimum function where you can find those points as well. Okay, and this will come up a lot more in 20-1. All right, okay. Let's talk about what we're going to do today because it is going to be something that we do basically mostly the last 10 minutes or so. We might do something else, but mostly we're going to be doing an investigation using these calculators. Okay, so I'm just bringing up our notes. And I want you to turn to page 5. And we're basically going to spend most of class doing this slope investigation. Okay? And you are going to take out your calculator, and you are going to graph 1, 2, 3, 4, 5 different equations on this page, and on the next page, another 5 equations. Okay, so 10 graphs altogether. I want you to do them one at a time. Okay, all of these equations are in a specific format, and that format is y equals mx plus b. And what we're trying to do right now is figure out what this all means. We're going to look at an equation, we're going to look at it graphically, we're going to look at certain features of the graph, and then try and figure out how we can connect the equation to the graph. Okay? So what I want you to do before you graph it is for each equation, I want you to write out what is the m value of this equation and what is the b value of this equation. So if I have y equals 2x plus 6, what's the value of m? Yeah. Okay, and b? 6. What about in this one, y equals x plus 6? What? Yeah, 1. Good, because the coefficient of x there is 1 and 6. Okay? So as you go along, you're going to fill that out first, and then I want you to use your calculator to sketch a graph. So on the Casio, I'm going to do the first 2 with you, and then I'm going to get you guys to do the rest on your own. Just because I have this up here, I will use this first. Okay, so I hit exit, and it brings me back to this y equals screen. Okay, now I don't want this one anymore, so I'm going to cursor up to that and wait till it's highlighted. And then if I want to delete it, I have to hit F2, which is right here. Okay, so I'll hit F2. It's going to ask me, do you really want to do this? And yes, I do. So I'm going to hit F1, and then it's gone. Okay, and then I can put a new graph in there. And the equation that I want to enter is 2x plus 6. And I'll hit enter, and then it'll allow me to draw that. Okay, so there it is. And you're going to do a rough sketch when you draw, when you do it on your calculator. And what I want you to include in the sketch is the x and the y-intercept. Okay, so you can now go over here on the Casio, and for this guy, if you want to find those intercepts, you hit G-solve. Okay, to get the X-intercept, you hit F1 for root, and that is the point -3, 0. And for the y-intercept, you hit G-solve again and hit F4 for y-intercept, and it tells you it's the point 0, 6. So I'm just going to put those on here. This is the point -3, 0, and this is the point 6, 0. No, 0, 6. There we go. Okay, so that's really all you have to include in that sketch. And then I want you to figure out the slope. Okay, so there's actually 2 ways that we could do this. We could either, going from one point to the other, use rise over run, or you could also use the slope formula, which we looked at on Monday, because we have 2 points. Okay, so I think if we're going to do 2 examples together, I'll just choose one of each. If we use rise over run, we don't pay attention to the values of the -3 and the 6, right? That's just where we are on the plane. You have to think about what directions are we moving to get from one to the other. We have to go up, and we have to go right. Up and right are both positive directions. Okay, so we are going up from 0 to 6, so our rise is 6. And our run, we're going from -3 to 0 to the right. That's 3 units right. Okay, and then 3 over 6 is 2. Yep.
Couldn't we also just run that to the equation, just m is slope?
We're going to get there.
Like, if that step, if we already know how to do it.
I'd like you to, I mean, I think that you may know that m is slope, and I've spoken about that briefly, but you may have just like recognized that m is slope, right? So I actually want you to like go through the steps of seeing why. Okay, All right, now, and I also want you to practice using features of the calculator. If that's all you get out of this, then that's good, okay? All right, now on the TI, let's do the next one on the TI. So this next one was y equals x plus 6. So I'm going to go to the y equals button again. And to get rid of this, I just press clear. Okay? And I'm going to go x plus 6. Enter. And graph. Okay, and there's my graph. And again, I want to find the x and the y-intercept. So to get those two things on this calculator, I have to get to that calc menu. So I'm going to hit second trace to get to calc. And the first two features are what I use to get each intercept. So number 1 value is for the y-intercept. And at the y-intercept, x is 0. Okay, so that's at 6. Y-intercept is at 6. And for the x-intercept, gotta get to that menu again, I hit number 2 for 0. Okay, and this is where it asks me for a left and a right bound. So here is kind of like the vertical line, if you imagine. So the left side is over here, the right side is over here. So I'm going to move my cursor to the left side and hit enter, and then to the right side and hit enter again, and then I'm going to ask it to guess. And that point is at -6, 0. And then just draw a little sketch. So this again is at 0, 6, and this is at -6, 0. Okay? And maybe this time, instead of using rise over run, we can use the slope formula to practice that. So the slope formula is y2 minus y1, 6 minus 0, over x2 minus x1, 0 minus -6. Okay? And that is 6 over 6, which is 1. All right, any questions? Okay, so you guys have 8 more of these to do. I'm going to write out the next 3, because some people don't have the notes printed, okay? I'll write out the next 3 maybe on the whiteboard, and then I'm going to move over to the next page so that you guys can see all of those ones too.
For half, would you just do bracket 1 divided by 2 bracket?
Yes, good question. So when you're entering in a fraction, this is on the calculator, bracket 1 divided by, 1 divided by 2, close bracket. Okay? Yeah, exactly. Okay, so let me move to the next page. I'm going to pause the recording for a bit while you work on this. When we started working on this first page, okay, what did you notice about the M and the B values? Yeah.
I noticed that the M value is always equal to the slope.
Yes. Whatever M was turned out to be the slope of the graph. Okay, so here M was 1/2 and slope was 1/2, right? Here M was -1/3 and slope was -1/3. Okay, and the last one, M was -1 and slope was -1. Okay, yeah, so that value of M that is in the equation shows up very clearly when we're looking at the graph. The M value tells us what the slope of the graph is going to be. Okay, what happened with the B values on this first page? Yeah.
B was the Y.
Yeah, so B was always 6, right? We kept that the same. And the Y-intercept was always 6, okay? Does the X-intercept sort of appear in the equation anywhere? Like we have all these different X-intercepts as well. Does that show up anywhere in the equation? Yeah. Well, when you're calculating your slope, yes. But the slope here is 1, the y-intercept was 1. The x-intercept was -6. Does that -6 appear anywhere in the equation? No, it doesn't, yeah. So the x-intercept actually, I mean, we could figure it out given the y-intercept and the slope, but it doesn't actually show up in the equation. Oh, I didn't start this. Okay, sorry. So the slope and the y-intercept show up in the equation, the x-intercept doesn't. Okay, and on the second page, what we did was we kept the slopes the same, but then the b values changed. So this was 4, 1, -2, -1. What was the b value here? 0, yeah, because you're not adding anything, okay? So this basically just confirmed the previous page, right? When we keep the slope the same but only change the b value, the only thing that changes is the y-intercept. And the y-intercept corresponded to all of these values, okay? So when answering these questions, what's the relationship between m in the equation and your slope on the graph? Yeah, they're equal. Yeah, they're the same. And then what's the relationship between the value of b in the equation and the y-intercept on the graph? Yeah.
The y-intercept is always equal to b.
Yeah, they're also equal, right? So we have a direct connection in the equation between slope and y-intercept, okay? For the last one, so a lot of you guys, some of you didn't get to this, but that's okay. This guy looks like this. Right? So I told you to find slope using the 2 intercepts. This one, it has 2 intercepts, but they happen to be the same value because the intercept happens at the origin. So what's another way that we could find the slope here? Yeah.
Find another point.
Yeah, find another point on the line. So you could do this one of 2 ways. You could use your calculator, like on the TIs, for example. If you enter in the same as finding the y-intercept, but instead of putting in x equals 0, you put in x equals 1 or something like that. You could do it that way. You could also use the equation, right? Y equals 2 times x. If x is 2, what's y? 4, yeah, so that's another point. If you find this point here, then you can use rise and run. Okay, yeah, so we did have to find another point there, and that's because the x and the y-intercept were the same, okay? Now, finally, let's look at this guy. Predict the appearance of -2x plus 4, okay? What is the slope? What's the y-intercept? Yeah. Yes. This is the y-intercept, and -2 is the slope, exactly, okay? This form of the equation of the line has a special name. It's called slope-intercept form or slope y-intercept form. And that's because when we have an equation in that form, we know exactly what the slope is and exactly what the y-intercept is. And an equation of this form always looks like this. Y equals mx plus b, okay? M and b are numbers, and they are the values of the slope and the y-intercept. So this is our slope, and this is the y-intercept. Okay? So very simple example, the graph of a linear function has slope 3/5 and y-intercept of -4. What's the equation? Well, to write an equation, all you need is the value of slope, which is m, and the value of the y-intercept, which is b. Yeah.
Would it be 3/5 m or x, and then
Okay. Almost. This is not an equation.
oh, y.
Y equals, yes, you must have that in there. Okay, exactly. Yeah, so you just put your slope in where m would go and your y-intercept where b would go. Okay, the second example is very similar. I'm actually going to skip this guy for now. We're going to come back to it. But what I want to talk about in the last few minutes of class is how do we go back and forth between an equation and a graph. Very, very, very important skill. Okay, Slope-intercept form is a super, super nice form to graph from. It's very, very easy to go from equation to graph and vice versa, from graph to equation, okay? So, for example, graph the linear function with the equation y equals 1/2 x plus 3, okay? Now, if this is our equation, what is one point that we know is on that line? Just from looking at the equation. Yeah.
3.
3 where?
Oh, 0, 3.
Yeah, the y-intercept, right? We know the y-intercept. So that's what we're going to start with. We're going to plot the y-intercept. Okay, that's a point that we know is on the line. And if I ask you to graph, I would expect to see several points that are on the line with the actual coordinates in there. If you just give me one and then kind of wing the line after that, you probably will not get credit for that question, okay? I need it to be very accurate, okay? So we're gonna plot the y-intercept. Now we know the slope is 1/2. So we can use rise over run. Rise is 1, run is 2, to get other points on the line starting at the y-intercept. That's what we're gonna do next. Get other points using slope equals rise over run, which is 1/2. What does this mean? 1, right 2, up 1, right 2. It's like a staircase. So I start here and I go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. If you want to think of the slope as being -1 over -2, then you go down 1, left 2, down 1, left 2. Then you get points on the other side. Down 1, left 2, down 1, left 2, down 1, left 2. Okay? But you only need like a couple points to plot a line. So here is our graph. And it should have arrows on either end because these lines are infinite. Okay? All right, here's another example. Graph y equals -x on the same grid. Okay, well, when you are graphing, good thing to do is identify what is the slope, what is the y-intercept. So this equation y equals -x, what is the value of m there? What is our slope? Yeah, m equals -1. Now, what I personally like to do when I'm graphing from slope-intercept form is if the slope is a whole number, or sorry, an integer, I should say. This isn't a whole number, it's an integer. Put it in a denominator of 1. Because remember, we want to think rise, run, rise, 1. Blah. That's a tongue twister. Rise, run. There we go. Okay. What about the b value?
0.
Yes, our b value is 0. That's our y-intercept. So this is where we're going to start. And here we go down 1, right 1, down 1, right 1, down 1, right 1. So down, right, down, right, down, right. You could also think of this as 1 over -1. So the rise is now positive, up 1, but the run is negative, left 1, up 1, left 1, up 1, left 1. Okay? And then you get points on the other side of the y-intercept. And then just connect them and draw some arrows, and you've got your graph. Okay? So I would like you guys to try this one. And then we're going to talk about going the other way. What if we have a graph and we want the equation?